We're in Rosen, Discrete Mathematics and its Application, section 12.1 on Boolean functions. And the section covers these topics. We'll cover a few of these in the video. All right, so what is a Boolean algebra? Well, with Boolean algebra, we basically have two allowable values. We usually will pick 0 and 1, although it's not necessarily that we use those symbols. It is often convenient, sometimes confusing, as we'll see in just a second. Then we also will have an operator called Boolean addition or Boolean sum, another operator called the Boolean product, and then an operator called complementation. And we'll see that these are more closely related to propositional logic, where the two values are more like a true and a false. The plus Boolean sum is more like a disjunction. The Boolean product is more like a conjunction. And complementation is more like negation than other possible analogies. All right, so the operators are defined as such. If we have 1 plus 1 in the Boolean sense, we get a 1. That's perhaps unusual, but that would be true if it was true or true, you would get a true. So that's the analogy to keep in mind. 1 plus 0 is 1, and 0 plus 1 is 1, and 0 plus 0 is 0. So it seems like normal math there, but it's not. This is Boolean algebra. The products has an even greater potential for confusion because 1 times 1 is 1, 1 times 0 is 0, 0 times 1 is 0, and 0 times 0 is 0 when you're dealing with regular numbers. That is also true when you're dealing with Boolean algebra. So the way to think about this would be like the 1 is like a true, and this is like an and this is like a true. Well, true and true is true, whereas any combinations of zeros inside of a conjunction will give you false. Okay. And then complementation is like negation. So the complement of 0 is 1, the complement of 1 is 0. The negation of true is false, the negation of false is true. And this is why we do chapter 12 in this particular book often after chapter 1. So, and that's what this next bullet says, that the analogy is to logical connectives into propositional logic. All right, so let's find the value of this expression. We have a Boolean product, then a Boolean sum, and then a parenthetic operation with a complementation. So let's take the parenthetic one first, and we'll do 1 times 0 gives us a 0, and 0 plus 1 gives us a 1, but it has a complement there. It's kind of covered up by my markings. And the complement will give us 0 plus 0, and 0 plus 0 is, of course, 0. Okay. And very important to understand that Boolean algebra is not binary mathematics. In binary mathematics, 1 plus 1 equals 1, 0 in binary. So it's not binary mathematics. All right, so let's talk about the functions. So our set of possible values we'll say is 0 and 1. Again, we could use different symbols, but those are convenient. And then if I want to create an n tuple of zeros and ones, I would say that that is a set of b to the n is an n tuple of zeros and ones. All right, x is a Boolean variable if it only takes values from our Boolean set, in our case zeros and ones. And then if we're going to have a function from Bn to B, that the function will have a value out of the Boolean set, then if it goes from Bn to B, then it'll be a function of degree n. So that basically means how many variables are in the input to the function. Here we have a function that has an input of 2 variables. That is, comes from B2. And the result of that function is we just take the value of the first element in the 2-tuple, the ordered pair. So, and this would be a function of degree 2. If we want to find all possible values of a Boolean function with the variables, we can do what's called a Boolean table. And you will see that this looks a lot like a truth table from propositional logic. Here we have a Boolean function of degree 3 because it's a 3-tuple that is an input. And if we want to see what all possible values it takes on, we'll create all possible values for our 3-tuple. And we'll use we'll use a column for each of the variable and a row for each possible combination. So you can see that we are going to have 3 columns, and since each one can have 2 possible values, it'll be 2 to the 3rd rows is 8, just like we would have in a truth table. In fact, you can often think of the 1 as a true and the 0 as a false, and it'll look very much like propositional logic. So for our case, to get all possible rows, we do 1, 1, 1, 1, 0, 0, 0, 0, or 4 of those each, and then we cut that down in half, 1, 1, 0, 0, 1, 1, 0, 0, and then the last one, 1, 0, 1, 0, 1, 0, all the way down. And now we can start to calculate the value of some of the terms inside of our Boolean function. I'll do x times y first, and that'll be 1, 1 with all zeros below it. And that looks a lot like the conjunction, as we said earlier. Z complement will just be the complement of the Z column, so 0, 1, 0, 1 all the way down. And then finally, we can um, do the Boolean sum of these 2 columns to get the value for our function. So 1 plus 0 is 1, 1 plus 1 is 1, 0 plus 0 is 0 all the way down, and the value of our Boolean function for all those inputs is contained in that column. So just like a truth table.